So the distributed GIS in a distributed and dynamic system, the geospatial data are usually distributed across different departments within an organization and among organization, either on internet or on the intranet or the internet. So the distributed GIS can potentially query and extract this distributed database rather than simply downloading the data directly into the end user local machines to combine with local data. Distributed GIS client should be able to search, download and assemble analysis tools on demand. The client have control over the function required for a particular task. So the distributed GIS is cross-platform and interoperable. So distributed GIS can be accessed across platform regardless of what operating system the user is running. The client of distributed GIS tend to be able to run in a variety of computing environment and platforms. To be able to access and share remote GIS data and function distributed GIS program require high interoperability. The open geodata interoperable specification and geography markup language by the OpenGIS Consortium (OGC) are attempting to lay the ground rules for GIS interoperability. So, uniqueness of geographic information on the internet, heterogeneous format resolution, scales, times, and domains. The power of GIS operations function. The value of geographic information will increase dramatically by providing GIS user with the capability of GIS operations. The disadvantage of traditional GIS, the high pieces of GIS software package, inaccessibility to the desktop GIS from location other than the computer on which the desktop GIS software is installed. Difficult to customize, proper, proprietary technology, and the lack of interoperability. Management perspective, globalization of geographic information access and distribution, decentralization of geographic information management and updates. So the user perspective, the need of distributed GIS processing to cope with increasing size and variety of geospatial data sets. The need for customizable GIS models for software package specialization. The demand for location based information from the general public due to the popularity of the internet and mobile devices. The implementation installation is not necessary. So the basic component of distributed GIS: client, n number of client, web server with application server, map server, data server. The client HTML. The HTML based client has very limited user interactivity. It is particularly inadequate for user to interface with maps and spatial objects. The client side DHTML, ActiveX control, Java applets, then plugins. So that user client side scripting like JavaScript or Visual Basic script to make the plain HTML dynamic. Then ActiveX control is a general components where that can plug into any application that support Microsoft Object Linking and embedding OLE standards. The Java applets resides at the web server and are downloaded from the server and executed on the client at runtime. They allow the user to interact directly with the spatial features on the map. So plugins, the software executable that run on the browser to extended the capabilities of web browsers. So the web server and application server, web server HTTP server respond request from client, sending exiting HTML document or ready-made map image to the client, sending Java applets or ActiveX control to the web client, passing request to other program and invoking other programs such as CGI that cloud process the queries. Web server and application server translator or connector between the web server and the map server, establishing, maintaining and terminating the connection between the web server and the map server, interpreting client request and passing them to the map server, managing the concurrence request and balancing loads among map server and data servers, managing the state, transaction and security. The map server, GIS server, spatial server, a major work hours component that fulfill spatial queries, conducts spatial analysis, and generates and delivers maps to the client based on the user's request. Filtered features data that are sent to the client program for user manipulating. A simple map image in a graphic format such as GIF or JPEG or a graphic element map that is composed of discernible map elements with predefined colors, styles, legend, and so on. The data server servers data, spatial and non-spatial, in a relational or non-relational database structures. A client application such as a web client or a map server gains access to the database through the SQL. Therefore, a database server is often referred to as a SQL server. Database middleware is often used to access different databases. There are three major database middleware: ODBC, Java Database Connectivity, and Object Linking and Embedded Database, ActiveX Data Object. Through SQL, ODBC or JDBC drive, the client application can query, retrieve, and even modify database records in the database server. These are the basic components: web server with application server, different client; map server, data server. Thin client architecture versus thin client architecture. So the basic components of distributed GIS: thin is the www browser, internet, web server, CGI, web server API, server is ASP, JSP in IMS. The major advantages of these models are central control, easy for data managing, generally cheaper, integration possibilities. Disadvantages are response time low, less interactive, vector data does not appear in client sites. OpenGIS by OpenGIS Consortium, ISO TC 211 by Technical Committee tasked by the International Organization for Standardization. The main goals of OGC are the full integration of geospatial data and geoprocessing resources in mainstream computing, and the widespread use of interoperable geoprocessing software and geodata products throughout the information infrastructures. ISO TC 211 emphasizes a service oriented view of geoprocessing technology and a balanced concurrent of information, application, and system. OGC. The OGC, a broad based alliance of government agencies, research organization, software developers, and system integrators, is engaged in a multi year effort to define OpenJS and to develop a set of requirements, standards, and specifications which support it. The overall goal is to encourage software developers and integrators to adhere to these requirements and through time create tools, databases, and communication systems that maximize the utility of systems and resources and take advantages of technological advantages. The major areas of research and development within OGIS include defining a geodata type hierarchy that comprises simple and complex features, maps and coverages, images and field datasets, and specifying the relevant interface. Developing a constant appearance to metadata to support data collection and browsing, enabling the concept of information communities which share common definition, information semantics, and data di- directories, dictionaries, thesaurus, and defining the basic data structures required for implementation. So the three broad requirements for OpenGIS: interoperable application, shared data space, and then heterogeneous resource browser. An OpenJS architecture must provide robust method for accessing multiple forms of data using multiple software environments. So the Open Geodata Interoperability Specification, initiated by the Open System Foundation, a comprehensive object-based framework to support distributed access to geodata and geoprocessing resources. The OGC was set up to oversee the development of the OGIS. The geography markup language (GML) is an XML encoding for the modeling, transport and storage of geographic information, including both the spatial and non-spatial properties of geographic features. The key concepts used by GML to model the world are drawn from the OGC abstract specification. The user presentation OGIS interface, Apple application server OGIS interface, spatial data access provide DBMS. The OGIS interface data store, yeah, the network distributed computing environment. The data sharing put application of distributed GIS put the raw data in the original format along with the metadata in their own website. Join a data clearing house network or a GIS data portal and list your data using the same standard or protocol of the data clearing house network or GIS data portal. Put data in a standard format like GML and make it available on the web. The geospatial information disseminations easier to disseminate information such as land use plan, zoning information, environmental information, and traffic information. Faster information sharing and exchange among different departments within an agency or across agencies. Online data processing, move analysis tool from desktop to online. User friendly web browsers interface make the GIS analysis tool easier to use. Component based distributed GIS architecture allows the development of interoperable geospatial analysis tools as individual and sellable geoprocessing components. The location based services, real time information, mobile GIS plus GPS. The future impact on the GIS industry, distributed GIS services will exploit the reusability and compatibility of GIS software and data object. Design of distributed GIS services can help the GIS industry migrate gradually from legacy systems and adapt to new technologies. Distributed GIS services will change the development strategies of GIS software vendors and will transform the current monopolized GIS market into an open competitive environment. The future impact on geographers is the geographer and spatial scientist can build more realistic model to solve their research problems by combine the GIS component and model in distributed GIS services. Distributed GIS services will help scientists and geographers focus on the domain of problems rather than mechanism of system implementation. The flexible data approaches and the operational metadata scheme in distributed services will help geographer utilize online information more efficiently and facilitate the reusability of geospatial data for geographic research. The future impact on the public, private, transparent, ubiquitous GIS services in daily life, deliver real-time integrated services for emergency event. The other research topic is geoportable interoperability web services technology. This is the future of distributed GIS system. So the interoperability is the ability of a system or components of a system to provide information portability and inter-application cooperative process control. Two geographical databases X and Y can interoperate if X can send a request for services R to Y on a mutual understanding of R by X and Y can return response S to X based on a mutual understanding of S as a response to R by X and Y standard. So the geoportal, yeah, technical definition of the world portal is a website consideration to be an entry point to other web location. Opening the terms geo and the result might be as follows. The geo portal, a website that present an entry point to geographic content and the web, are more simply a website where geographic content can be discovered. Metadata. So the US Federal Geographic Data Committee Clearinghouse web site represent one of the yearly facial data infrastructure web portal initiative. So the assessment of this session is list the application of distributed GIS through the federal for driven by the first US presented requirement to support the sharing of geographic information, the National Spatial Data Infrastructure or NSDA. The assessment is application of distributed GIS. These are the reference material. These are the reference These are the reference material. Thank you.